Let's continue with problems based on particular functions. In the last session we have seen problems where we of the form of 1 by a square minus x square, 1 by a square plus x square, or 1 by x square minus a square, or dx by ax square plus bx plus c, or px plus q by ax square plus bx plus c. We'll see same type of problems with a square root, and we know the formulas for them, so we'll go ahead and try to solve them. Let us say we have been given, suppose dx by square root of 1 plus 4x square. Now we have two ways to solve this problem. One, you can take that 4 common, then you can make it as x square plus some constant square, then you apply the formula. Or you can also do 2x equal to t, and you can convert that as integral of, we'll do 2 dx, differentiation will get 2 dx, 2 into dx equal to dt. So I can say 1 by 2 dt, because dx is dt by 2, divided by 1 plus 4x square is nothing but 2x whole square, that is t square. Or can I write one more step here, dx by square root of 1 plus 2x whole square. Now once we got in the form of square root of a square plus x square, we know the answer is log of x plus root of a square plus x square, or in this case log of t plus root of 1 plus t square, which is nothing but equal to half log t is 2x plus root of 4x square plus 1 plus c. So we have to just basically convert them into one of the format. We have to see which format they will fit into, and then we have to go ahead with that. The same problem can be also solved by taking 4 and write it as 4 into x square plus 1 by 4. Then this root 4 will come out and will become 1 by 2. Then you can do root of x square plus 1 by 2 whole square. That is also correct, and you will get the same answer in that particular situation also. Let's see one more problem. We have to find out the integral of 1 by root of 9 minus 25x square. Again, I am tempted to look here, this is 5x whole square and 3 square, so I'll write it as 3 square minus 5x whole square. I will say 5x equal to t, then I will have 5 dx equal to dt. So I'll go back to my next step and say integral of dx is 1 by 5 dt, so it will be dt divided by square root of 3 square minus 5x is t square, which is equal to 1 by 5. This is in the form of, we are in the form of here square root of a square minus x square, 1 by square root of a square minus x square, for which the integral is sine inverse x by a. So we know that, so we can directly substitute that, that is 1 by 5 sine inverse x by a, or here t by 3, that's equal to 1 by 5 sine inverse 5x by 3 plus c. So we have to look into how we have to convert them into one of the standard format. So this is one way of doing it, where you take 5x equal to t, or if you want, you take 25 common, it will become 25 into 9 by 25 minus x square, then you will have 3 by 5 whole square minus x square. You will end up with the same answer. Okay, let's go to the next one. We have to find out the integral of x minus 1 dx by root of x square minus 1. What we will do, we'll try to separate it now. We will say integral of x dx by root of x square minus 1 minus dx by root of x square minus 1. We know this is easy because it's root of x square minus a square. So we know that that's nothing but log of x plus root of x square minus a square. Now only the thing is how to find out the integral of x dx by root of x square minus 1. for this part, what we will do, we will say x square minus 1 equal to t. That gives us 2x dx equal to dt. Why we have taken x square minus 1 equal to t? Because we see x dx here. The idea is always to kill the numerator part as much as possible. So x dx equal to now half of dt. We are doing only the I1 part. We are not doing I2 as of now. This is I1. 1 by 2 integral of x dx is dt divided by square root of x square minus a square, that's equal to t. So that is 1 by 2. We know integral of dt by root t is equal to 2 root t plus c. That's equal to 2 will cancel. You get root 2 plus c. That is equal to root of x square minus 1. So the first part answer for this is root of x square minus 1. Now for the second part we know it's directly dx by square root of x square minus a square, that is x square minus 1 square, which is nothing but equal to log of, as per the formula, x plus root of x square minus 1. So we can directly replace integral of dx by root of x square minus 1 with log of x plus root of x square minus 1. So the whole answer is root of x square minus 1 root of x square minus 1 minus log of x plus root of x square minus 1 plus c. That is the answer for this particular problem. So we have divided that into two parts, because we see we can find out 1 by root of x square minus a square, but we don't know how to find out, when there is numerator other than constant, there is some variable. So the only way is how to separate them. We have separated them, x and as 1 in the numerator, it becomes x by root of x square minus 1 minus 1. Again we see in the first I1, I can take x square minus 1 equal to t, then x dx will be dt by 2. So that helped us to solve the problem. So let's go to the next one. So let's try to solve this problem. We have to find out the integral of root of dx by root of x square plus 2x plus 2. So we have to convert this into one of the standard forms. For that we have to do complete the squares method. So let's write it down, dx by square root of, how can you write x square plus 2x plus 2? We can write it as x square plus 2x plus 1 plus 1, and this is nothing but x plus 1 whole square. So the next step will be dx by square root of x plus 1 whole square plus 1 square. We can take x plus 1 equal to t. We will get dx equal to dt. So the next step will be dt by square root of t square plus 1 square. We know the formula for 1 by square root of a square plus x square, that is log of x plus root of x square plus a square. Therefore the answer will be log of x is t here, t plus root of t square plus 1, which is nothing but equal to plus c, which is equal to log of t is x plus 1. So we will have x plus 1 plus square root of x square plus 2x plus 2 plus c. So whenever we have dx by square root of ax square plus bx plus c, anyway here a equal to 1, we have to see how we can convert that into one of the standard form. Then you should be able to solve this very easily. Let's do one more problem. Let's look at this problem. We have to find out the integral of dx by square root of 7 minus 6x minus x square. If you see here, the x square coefficient is negative. That means we will be going into the format of square root of a square minus x square. And we know integral of that is equal to sine inverse of x by a. So, now first let's try to convert this into square root of a square minus x square format. For that, what I will do, dx by, I will write square root of 7, I will take minus common, I will say 6x plus x square. Now we'll try to use complete the squares method here, and we will say dx by square root of 7 minus, I have x square which is a square and 6x which is 2ab. That tells me that 2 into x into 3 and b equal to 3. So I should add plus 9 and also I should subtract minus 9 so that it will not change. What I have done there, I have x square plus 6x, I have added plus 9, I have subtracted plus 9. The idea is to convert this into x plus 3 whole square. Now when you compare them, you have x square plus 2 into x into 3. So 3 square is 9 and you are in the form of a square plus 2ab plus b square. That is completing the squares method, right? Okay. So the next step will be nothing but integral of dx by, now I will have square root of 7 minus of minus 9. So I will say 7 plus 9 minus of x square plus 6x plus 9. That's equal to integral of dx of square root of 4 square minus x plus 3 whole square. Now we are into the format what we want, a square minus x square format. So we can write down the answer now. That's equal to sine inverse x is x plus 3 by a is equal to 4 plus c. So the answer is sine inverse of x plus 3 by 4 plus c. So how we have done that? We have seen that the quotient of x square is negative. That means we know it is of the form square root of a square minus x square. So we have to convert this into the form of square root of a square minus x square. For that we leveraged the completing squares method. We have seen here a square and 2ab, b square term is missing. We added the b square term, we subtracted the b square term, and when you simplify that, you will have that's nothing but 16 minus of x square plus 6x plus 9, or 4 square minus of x plus 3 whole square. We can cross check that 16 minus 9 is 7 minus x square minus 6x. So we are good to go. Once we know the integral of dx by root of a square minus x square format we are in, we know that the integral is sine inverse of x by a. So we can write down it as sine inverse of x plus 3 by 4 plus c. Let's see one more problem.